This video is going to talk about exponential decay, which is pretty much what we did with exponential growth, but this time the graph is decreasing. So it's a decreasing exponential graph, and that application is called exponential decay. So here are the formulas again. They work very similar to the ones from exponential growth. If it's decaying by a percent, the only difference is that you're going to subtract r instead of add r. And the other application with decay is what we call half-life. And half-life is the amount of time it takes for a substance to cut in half. Half-life is used in many different types of substances. One example might be medications. So if you take a medication like ibuprofen, which is the same as Advil, it has a half-life of approximately 2 hours. So here's your example. So if you took ibuprofen, which is Advil, and if you took 400 milligrams at maybe 12 o'clock p.m., the half-life is 2 hours. So at 2 p.m., you would have half as much. So then you'd have 200 milligrams. And then you'd have 100 milligrams at 4 o'clock p.m. And the half-life here of different medications is what allows the doctor to say how long between medications you have to go before you can take another one. So when they say you have to go 4 to 6 hours before taking another Advil, it's because they have to make sure that the amount gets decreased enough so that when you take another one, you don't have too much in your bloodstream. So that's what half-life means. So that's why with the half-life formula, what you're doing is you're taking the initial amount A and you're cutting it in half. And then the formula is the same. X is the amount of time, and the H is what the half-life is. So we're going to look at two examples. In the first example, it says that China's one-child policy was implemented in 1978. So the idea in 1978, they had said that parents in China were only allowed to have one child. If they had more than one child, then they were subject to fines, or their access to government assistance became more difficult. But that's not really the point of the story here. The whole point was that they wanted to reduce the population to 700 million by the year of 2050. China's population in the year 2000 was about 1.2 billion. So suppose that China's population declines at a rate of 0.5% per year. What is the population expected to be in 2050? So because this is not half-life, we're decreasing by a percent. So you're going to use this formula. F of x equals a times 1 minus r to the x over p. So the a is the initial amount, which is 1.2 billion. And r is the decay rate, which is 0.5%. And remember, that has to be a decimal. So you have to divide that by 100. So that is 0.005. Your x is the time. So that is the time between the year 2000 and the year 2050. So that is 50 years. And the p is how often the percent is decreasing by. So it's per year. So that means the p is equal to 1. So substitute that in. That's 1.2 times 1 minus 0.005 to the 50 over 1. You just have to write 50. And if you want, you can change that 1 minus 0.005, and you can change that to 0.995. You don't have to. You can just type in the bracket 1 minus 0.005 in your calculator. But anyway, in your calculator, this works out to, now that works out to 0.934. Oops, that's rounded, so that should be approximately. Now that's in billions, so that means, therefore, the population in the year 2050 would be approximately, you could say 0.934 billion, or you can write that as 934 million. So as you can see, they wanted to get it down to 700 million, but that decay rate only would bring them to 934 million. Not that it's part of the question, but they no longer have the one-child policy there. All right, the next question is, the pesticide DDT was widely used in the United States until its ban in 1972. DDT is toxic to a wide range of animals and aquatic life and is suspected to cause cancer in humans. So this is a half-life question, and the half-life is approximately 15 years, so that's the value of H. So our half-life formula is f of x is equal to a times a half to the x over h. And your initial value in the question, it says we're starting with 100 grams of DDT. So the initial amount is 100 grams. The time, it says in the question, after 100 years, so the time is also 100. And the half-life is 15 years. So if you substitute that into your equation, you get 100 times 1/2 to the 100 over 15. Now, an easier way to type this into your calculator, instead of 1/2, you could write that as 0.5. But in your calculator, you remember you would type this in as 100 times 0.5, and then whatever your exponent button is, everyone has a different exponent button, and then bracket 100 divided by 15, close the bracket, equals. And that is approximately 0.98. So therefore, there is approximately, oh, so this is something else you should keep in mind. It's 9843. And for rounding, what you want to do in this case would be to round up always. Because after that 100 years, if you were to round there or if you were to round there, you wouldn't just have 0.98 because there would still be that 0.4. You'd still have a little bit left. So technically, if you were to round it, you would have to say there is approximately 0.99 grams remaining. Because if you say there is 0.98 grams, well, there's actually more than 0.98, so we haven't gotten down to 0.98 yet. So if you remember last day with the exponential growth, we always rounded down. So with exponential decay, you'll always round up.